So let's start from the beginning. What do I mean when I say API governance? Basically, I'm talking about the decision-making process around an API or an API portfolio. If you look at the process to move an API from design to production, there are so many decisions that must be taken, and so many different stakeholders. There are technical stakeholders, the actual team building, designing the API, all the way up to the API product owner. That is the one that has to productize it. So any help, tool, framework around this decision-making process is what I label as API governance. And at the core of this process, there's this kind of information loop, no? When you first need to understand what is going on, what APIs, what is the quality, the attributes of those APIs. You need to measure that, and on top of that, make decisions. You need to define some metrics, define a direction for your API or API portfolio. And once you have defined it, you want to take action. And obviously, this is a loop. It repeats, and little by little, you evolve towards that direction. The other interesting thing about the API governance process is that even if I'm going to focus on the API interface, on the design, it needs to cover all the aspects of the API. And at the very core is this kind of intersection between the interface, the actual contract, what you put in an API spec, usually, that is the set of data capabilities your API is exposing. You also have the API instance, there's the actual runtime that contract needs to be accessible somewhere through some network protocol, and usually it's there where you apply API management, for example, the runtime. And obviously there's also an implementation. Some code needs to implement that contract, and is what you make available at the runtime. And this is a very narrow technical definition. If you think about the API as an API product, this explodes in complexity. There are so many aspects there that are important. Sorry, let's see if I can remove my notifications from work. Sorry about it. If we focus on API design, we are talking about the interface. That is usually what you encode in one API specification. And one thing we see in MuleSoft is just there is really no one single way of defining APIs. I really think the present and more the future is going to be fragmented. There are going to be different types of API with different types of defining the API contract metadata, some of them more mission specific, some more general, but you need to deal with all of them. So if we want to start looking, so try to make this more concrete and start thinking about how we could implement an API governance layer. This is kind of a small architecture. No? The core of this is the API catalog. You need a place when you store all these related metadata from all the different aspects of the API. And then the next thing you need to do is to bring the information into the catalog. And there have been many sessions today about API ops. The CI/CD pipeline is naturally, like the natural place to try to inject or extract this metadata. That will cover many of the spec, implementation, or runtime aspects of the API. But it's not the only one. Another thing that is very interesting for us, for example, is runtime discovery. Because sometimes the stakeholder that is looking for API governance is not directly connected to the API teams. So just going to the runtime, I'll be able to extract the information about the endpoints, the instance, and the specification is a viable approach. Once you have brought this information into the catalog, this metadata into the catalog, is when you provide the key capabilities of a governance layer. The analytical capability, you really want to run some queries, queries about the types of APIs, number of endpoints, complexity of the spec, this kind of information. You need to define metrics, because you need to measure if the API specification, if your portfolio evolves. And obviously, you need reporting. And when you move to act, the key aspect there is this set of rulesets. If you want to enforce something, if you want to try to steer the process in some direction, you need to check how the metadata that you are storing in the catalog gets produced. And you need to bring those governance rulesets into the development process and the CI/CD pipeline. You need gates, you need enforcement gates. So this is kind of a toy model, but obviously reality is more complex, but can help steer the discussion. And if we're going to focus on the interface on API design governance, the interface is the key aspect there. And what I'm going to do in the talk is try to discuss some open source components we have built in MuleSoft that can help you build your own governance layer. So the first one is AMF. AMF is our API specification, API metadata parser. Right now, AMF, for example, can take as input RAML, OAS, AsyncAPI, GraphQL, gRPC, parse it, and generate a JSON LD graph as output. And it's not only generating a JSON LD graph output, it's only generating a common model. So it's able to take all these different API specs and generate a consistent common model describing the API behind them. AMF can do all their other things, but this generation of the JSON-LD is the most important from the governance point of view, because the JSON-LD, for example, you can take it and directly store it in some kind of analytical database that allows you to query and manipulate the JSON-LD. For example, in MuleSoft, we're using Neptune as our core repository for metadata. The interesting thing of AMF is not only limited to the API spec. As we were mentioning, this process of extracting the information of the API is a process at the end of the day of extracting metadata, and not only extracting that, connecting that and linking them. So for that, for example, we're using AMF also to parse Kubernetes descriptors, Istio configuration, and since we produce JSON-LD out of that, it's very easy for us to link it and connect it into a single graph of metadata that describes all the aspects of the API. This is the basis of our governance capability. We are releasing very soon a plugin for AMF that allows you, basically, if you have a JSON schema, very easily generate JSON-LD with right semantics and linking the information. And in that way, you basically can generalize what we do for API specifications for almost anything. And this is an example of how AMF works for 4 different types of APIs. Here, the syntax of the API is different. We have RAML, OAS, GraphQL, and gRPC, but the actual API contract is the same. Obviously, each of API has different details. The binding to HTTP will not be the same as in gRPC. Things like, for example, the order of the field is very important in gRPC, but it's not that important. It doesn't exist as a concept on RAML and OAS. But at the end of the day, from a high-level point of view, the contract is the same. And that's important when you're declaring governance rules that they don't really care about the actual HTTP or gRPC binding. Things like, for example, endpoints must be documented is something that can be enforced and declared once and applied to every single type of API. This is the model that AMF will generate for these 4 APIs. It's exactly the same one for RAML OAS. There are small details that change in GraphQL and gRPC. And basically, it's this graph with 6 nodes: the web API, the endpoint, the operation, the response, the payload, and the shape. And you can see how these nodes are connected by different properties, like the endpoint, the operation, etc. If we go one level down, this is the actual JSON-LD. And JSON-LD is basically JSON with a couple of things. There's this type properties that allows you to provide semantics for the node. So we have seen this is not just a JSON object. This is a web API. This is an endpoint. And there's the ID. The ID is very important because it allows you to link the nodes. In this way, you can basically have not just a JSON document, but this connected graph of metadata that is, for example, in the next part, what we are going to validate. If you want to know more about AMF, it's completely open source. You can get it there. All the documentation is available. Take a look if you're interested. The second component we're open sourcing is the rule set and custom validator for AMF. The validator basically is a small, simple rule language and translator that takes some JSON-LD, applies some rules, and generates a validation report. The way the validator works is by translating this YAML syntax for rules we have described, we have defined into a small subset of first-order logic, and then doing translation to Rigo. This means that basically we can speed Rigo, and you have an OpenAPI agent somewhere can just do the validation for you. This is really interesting because Rigo is becoming kind of the standard OPA for doing CI/CD validation, so it's very easy to port these rules and apply them, in your existing infrastructure. The interesting part about the translation is that it's quite formal. So we are basically being compliant with SHACL. SHACL is a standard from the W3C to encode shapes of JSON-LD graphs, RDF graphs. We passed all the SHACL test suite, so we are compliant. We are pretty sure the thing is correct. And this is a small example of a rule. So this is a version format rule. And basically it's saying, get this web API node, any web API node in the API, and check that the version property matches this regex. Probably the most different part with other declarative language rules is that it's not based on path traversal. We are not validating the AST of a document. We are validating the JSON-LD graph, the semantic graph we generate. So basically, you have this target class that allows you to select the type of information you are validating. You don't always need to start from the core, the top of a document AST, and get to the information and validate it. And also, again, since different formats generate the same graph, you can have rules that are common for very different type of API specifications. These individual rules, we store them in profiles that allow you, basically to set the severity level. And we also allow you to do inheritance between profiles. You can disable some rules, etc. All these things, for example, we package them and we store them in our Exchange so people can work on versioning the rules, evolve them, and reusing them as dependencies in their API projects. And this is a little bit a summary of the kind of validations we support right now in the YAML syntax. The basic constraints you might be expecting for individual properties, regular expressions, min count, max count, length of strings, these kind of things that are commonly available in any schema language. We also support property paths, so it allows you to, from any point of the graph, to navigate the graph in a very flexible way, with alternative paths, doing inverse paths. We allow you to compare pairs of properties, to check different values in related properties. These basic rules can be composed using Boolean logic to do very expressive rules. And then we also allow you to nest different constraints for different nodes to have complex shapes across the graph. Existential quantifiers, if then else. And if this is not enough, you can always just introduce your small Rego snippet and do whatever you need to do if it's not covered by the standard syntax. The also interesting thing about this is not limited to the API specs graphs we are generating. If you have an arbitrary JSON-only document, you can validate it with this. That's the reason we also introduce the support for namespaces if you are using different semantics. Some of the links we provide, the validator is there. We have a CLI to allow you to develop the rules, test them, if you want to have your own CI/CD pipeline for the rule sets. We have a Visual Studio Code extension that will allow you to have auto-completion and suggestions if you are writing the rules, and a fairly complete tutorial if you want to learn how to build these rules. One thing I forgot about this is that basically a lot of them are basically translation from Shackle. So we have this backup of the standard behind it. And if for some reason you're interested in having a Shackle validator with nice syntax, you can also take a look. And all of these things, we are productizing them in MuleSoft. So our API governance product is basically a UI layer on top of this catalog governance and validation capabilities I've been describing before. So this is the talk, a short one. If you have any questions, I'm happy to answer. If not, thank you very much for being here. No, it's productized. It's basically, we are open sourcing the capabilities behind our product, the core capabilities. This is in production. MF has been in production for 5 years almost. It's very, very robust. So, no, it's not conceptual at all. Thank you.